Okay, we're looking at question 4 here. Got a balanced equation with some aluminum sulfide reacting with water to form aluminum hydroxide and H2S. And it says if we have 15 grams of aluminum sulfide and 10 grams of water, we're going to allow those to react and then answer all of these problems down below. All right, so part A wants us to calculate which is the limiting reagent. Now, typically when we get a question about limiting reagent, since there's more than one way to solve it, I typically look at the very next question to see if it gives me an idea of how I should solve this. And part B, it says calculate the mass of H2S formed from these two. So what I'm going to do, just to make sure I get this right, is I'm going to take the 15 grams of aluminum sulfide, like it gives there, and the 10 grams of water, and I'm going to do two calculations in part 1, and both of them I'm going to figure out the amount of H2S that would be produced from each one of those components. Alright, so I need to get the molecular weight of aluminum sulfide. So aluminum has a mass of 26.98, and sulfur, there's 3 of them, and that has a mass of 32.06. So I get a molecular weight of 150.14. My stoichiometric ratio, I have 1 aluminum sulfide for every 3 H2S's, and 1 mole of H2S happens to weigh 34.08 grams. Alright, down here, before I do a calculation, I'm also going to do the same conversion, but now using the 10 grams of water. This will be different. It is still 3 moles of H2S, but in the balanced equation it's 6 moles of water, and this conversion will be the same. 1 mole of H2S is 34.08. Now technically what we're calculating for both these is the theoretical yield of H2S if you use up all of that starting ingredient, so all of the 15 grams of aluminum sulfide. So we'll do this first. So 15 divided by the 150.14 times 3 times 34.08. We get a theoretical yield of aluminum sulfide of 10.2. And the 10 grams of water, 10 divided by 18.016 times 3 divided by 6 times 34.08. We get that to be 9.45. I'll go 46, rounding up. Alright, now these are both theoretical yields, and that's assuming on the first one all 15 grams was used up, and on the second one all 10 grams was used up. Now technically, since this one is the smallest, what that says is once we've used up all 10 grams of water, we'd still have some aluminum sulfide left over, because we're not getting up to that 10. So the 9.46 tells us two things. It is the answer to B, that's how much H2S is produced, theoretically. And it also tells us that water is limiting. And technically we can even do this last thing. Very similar calculation. It wants us to calculate the mass of excess reagent. We know the limiting reagent is water. And we'll do the same first step because we need to have it in moles to do anything useful for it on relation in that balanced equation. But what we're going to compare it to is our other reagent. So we have that 6 H2Os, but we want to figure out how much aluminum sulfide is getting used up. I guess that should be a 3. And that's that 150.14. All right, so what this conversion is doing is taking those 10 grams and telling us how much grams of aluminum sulfide we actually will use. 10 divided by the 18.016, and then divided by 6, and then multiplied by 150.14, we get an answer of 13.9 grams. Where'd my pen go? There it is. Now that's how much gets used. This one wants to know how much is excess is remaining, and to get that I'm just going to do 15, the starting amount subtracted from that. And I get that I have about a gram left over. 1.1 grams remaining. Not bad at all. Alright, but you'll notice on these type of problems you're always doing 3 conversions. You're going to start with what you have and convert that into moles. You will always do a stoichiometric ratio to turn it into what you want to relate, and then most of the time you're going to actually turn that into a mass by using the molecular weight of what you have. So molecular weight, stoichiometric ratio, molecular weight. And just let the units always set it up. If you're not sure how to balance it out, just remember that whatever's here is going to be canceled out down below. This gets canceled out for the next step. This gets canceled out for the next step. It always does that, and you end up with the units on top of that last step. All right.